Yesterday I forgot to do a video over reflections in the coordinate plane. Today what we're going to be doing is we're going to be applying certain rules. Like for example, if you go across the x-axis, what happens to the x and the y value? What happens? The x stays the same, but what happens to the y value? It becomes the opposite, right? If we were to go over the y-axis, what happens with the x and the y value? What stays the same? The y value stays the same, but what happens to the x value? It becomes its opposite. I like it. Oh, now this over here, this was a little tricky. This is across the origin. This is not line symmetry. This was the only one that is what? Point symmetry. Which means we are going across a point, not across a line. So for example, when I say what is across the line, let's give you a quick little example here. Make it a little bit bigger. Here we go. So across the x-axis is across this axis. Across the y-axis is right there. Across the origin is not across a line, it's across a point. So what happens with your x and your y? Ooh, you get a negative x and a negative y. And last but not least, we have the last line symmetry that is on right here. And that is across this wonderful line called y equals x. This is kind of cool. Your x and y, what happens to the x and the y value? They become a y comma x. They actually switch places. And that's what we did yesterday. Today we're going to do a few examples. All right? We're going to apply these rules to the final problem right here. To problem number 4. We're not going to do all these. We're just going to do it to problem number 1. Oh, I'm sorry. All right. So right now, the first thing you look at is you look at this trapezoid and realize, ooh, we're going across the what?
What?
The y-axis. So, by the way, what is the rule for the y? So if we have an x and a y value,
Sorry.
it's okay. The calculator has been hurt but not destroyed. Okay. What's the rule for the y-axis? Go ahead. The x becomes the opposite, but the y value stays the same. Let's check. Oh, you're right. Ta-da! Okay, so what we're going to do first, we're going to label H, then we're going to label I, then we're going to label J, then we're going to label K. So here we go. We're labeling them right now. If you've already done this, just check your work if you've already done it. Okay? So right now we're starting with a what? A -2 and a 5. Then we have a 2 and a 5. Then we have a -4 and a -1. And lastly, we have a -4 and a 3. Now, when you're doing this, it is very important that you plot these points correctly. All right, so we go -2, up, 1, 2, 3, 4, 5, you put 4. And you label that H. And then you go over 2, and up 5, and you go, and you label that I. And then you do J, which is -4, -1. You label that J. And last but not least, you do -4 and what? +3, right there. And you label that K. Then and only then do you do the last thing, which is connect the dots. Just like one of my favorite places that I used to eat at all the time when I was a kid. Oh, that's horrible. What did I do wrong?
You put it on 5.
Oh, I put it on 5. Let's go back. I thought I did something wrong there. You know what? It's okay. We have this wonderful thing called an eraser. Boom. There we go. There's -4, 3. That's what happens when you stand off to the side and don't look directly in front of it. Of course, you can't hear that or see that if you're just watching this. Right now, I'm blocking students' vision, so just don't mess up either. There we go. Aha! And what is that, everybody? That is a trapezoid. There's our trapezoid right there. Okay? So that's the original trapezoid. Now what we're going to do is we're going to make the image of it. So please put H prime sorry, Optimus Prime will not be listening.
Oh,
I know.
oh, what the heck?
Oh, wait, I'm supposed to
Very good.
It's okay. Don't worry. It's not being recorded for all to hear. Right? So, right now, what do we need to do? This is an x comma y. We got to become a negative x comma y. So, by the way, does the y change at all?
No.
No. So I'm just going to keep all my y values the same. So I'm just going to listen. I got 5. I got 5. I got a negative 1. I got a 3. So all the y values stay the same. What happens with the x values? They become the opposite. So now I have a 2.
2, 4.
There we go. So now I'm going to plot these. Here we go. We got a 2 and a 5, which is this point right here. Interestingly enough, that's I, so this actually becomes what? H prime. Negative 2, 5 is right here. This is H. This is actually becomes what? I prime. And then we have a 4 and a negative 1 right here. And that becomes J prime. And last but not least, I won't mess this one up. We have a 4 and a 3 right here. And that becomes K prime. And then and only then, what I'd like you to do is connect the dots once again. And hopefully, you can clearly see that this does in fact reflect across what? Across the y-axis. Can everybody see how those points are directly across from the y-axis? So what I'd like you to do after you're done, I'd like you to just shade this nice, beautiful trapezoid. By the way, it's a nice box of these trapezoids. We like those. They're special trapezoids. The legs are congruent, the faces are parallel. And that right there is your final answer for number 4. All right, now moving on, let's go to the back page. Not the back cave, but the back page. Okay. And let's look at problem number 5. Problem number 5 says, if quadrilateral JKLM, that's this one, JKLM, is reflected across x equals negative 1 to become J prime, K prime, L prime, M prime, what will the coordinates of M prime be? Well, in order to do this problem, you actually need to know how to graph x equals negative 1. That's the only way you can do this problem. If you don't know how to graph x equals negative 1, you're not going to get the right answer. So we're going to graph x equals negative 1 together. Right now, this is what x equals negative 1 looks like right there. So, Sierra, I got a question for you. What's my x value right there? What's my x value? Negative 1. Okay, what's my x value there? What about there? Negative 1, right? What about there? Anyway, this is the line where x is always equal to what? X is always equal to? Negative 1, that's right. If it said x equals positive 1, I would have put the line right there. If I said x equals a 5, then I go 1, 2, 3, 4, 5. Then I put the line right there if x equals a 5. But it says x equals a negative 1, so that's why I do a vertical line. So everybody, if you would please, on your paper, draw the line in, put x equals negative 1 so you know what it looks like. Now, this problem did not ask you to do this, but check this out. If I wanted to reflect every single point, this is what it would look like. I go over 2 and go over 2 more, so this would be my J prime. See where K is? I go over 2 and over 2 more, and that would be my K prime. All right? M would go from 1, 2, 3, and 1, 2, 3, so it goes right here. This point would be my M prime. That's the one it's looking for. But if I asked you for the L prime, 1, 2, 3, 1, 2, 3, this point right here would be my L prime. So what are we searching for? It says search for the coordinates of M prime. And so from the origin, it looks like I go over 1, 2, and then down 1, 2, 3. So M prime is over 2 and down 3. And that's your final answer. Why did I do all 4 points? I want to make sure you understand. I could ask you a question and ask for all 4 if I wanted to. Okay, so you want to make sure you know how to do it. And that's your answer for number 5. If all you do is write down the answer and you don't do all the other work, well, you know what? You're just failing yourself. Right. See here. quadrilateral QRST is shown below. It says, if quadrilateral QRST is reflected in the x-axis, then the y-axis, so we got to do order here. Order matters. Here we go. What are we going across first? We're going across the x-axis. Then what are we doing? Then we're going across the y-axis. It says, what will the coordinates of T double prime? Why do they call it T double prime? Because it's not just one move, it's two moves. All right, here we go. So right now, grab the T. See the T right there? Now, where are we going to go across first? X. 1, 2, 1, 2. What I'd like you to do is put the point right there and call that point T prime. Got it? Because what did we go across first, everybody? We went across the x-axis. Now, what are we going to travel across? We're going to travel across the y-axis. So now we go 1, 2, 3. 1, 2, 3. Put a point right there, and I'm going to call that T double prime. That is your ordered pair. So what does T double prime become? 6 and
4.
and that's your answer. Now I didn't make you do all of them, but that's how you would do each one of them. You would go first across the x-axis, and then you would go across the y-axis.
You do it all. You do it all.
Sure, I'll do all. Here we go. So we're going to do Q, all right? So Q would go right here. That would be Q prime. And then I would count 1, 2, 3, 4. 1, 2, 3, 4. And this point right here would be Q double prime. R would go across the x-axis. 1, 2, 3. 1, 2, 3. And be right here. And that would be R prime. And then I would go over a half and one more. So 1 1/2 would put me right here. Okay, and that would be R double prime. Which would be at a what? A 3. This would be at a what? 3 and a -6. This right here, Q double prime, is going to be at an 8 and a +1. And then we have, what's the last? Oh, S. So what do we got to do? We got to go across the x-axis, right? 1. Go down right about there, right? 1 1/2. Okay. And then that would be S prime. And then I would go over what? 1 1/2. Again, that would be right in there. So this would, this would be right here. This would be S double prime. Where am I at? I'm at a -3 and a -3. So this answer would be -3.
How did you draw your lines?
Well, you just connect the double primes. So this is what it would look like, all right? The final answer, if I were to connect all the double primes, I'd have to search for the double prime, all right? So what's the, it's going to be, start with Q. So start with Q double prime, right here, right? Where am I going to go to? R. So I'm going to find R double prime. Ooh. Then, what do I have to go to? S double prime. And then what would I have to go to? T double prime. And then I finish up. So that's what the final result would look like if I said, draw everything. But I just asked you, I didn't ask you for all of them. What did I ask you for? Just one coordinate. So what would your final answer be, everybody? If I said all of them, this is what the picture would be if I said graph the image. If you had to go across the x-axis and then across the y-axis. Okay? Okay. Number 7, it says, if triangle PQR is reflected across y equals -2. So where is y equals -2? It's right there. There's y equals -2. So I'm going to draw that in. Okay? Right now I'm drawing in y equals -2. It says to become P prime, Q prime, and R prime, what will the coordinates of R prime be? Alright, so if I wanted to plot these, how many units do I have to go down for P? I have to go down 3, right? So I got to go down 3 more, and what would that point be right there? That would be P prime. Go down 3, go down 3 more. That point right there would be R prime. How many points would I have to go down for Q? 1, 2, 3, 4, 5, 6. 1, 2, 3. I'm getting estimated, right? 4, 5, 6. So probably right about in there. And that would be your Q prime. We kind of ran out of real estate, but that's okay, because we can use our estimating skills. Estimating is pretty important in life. Okay? So right now, what are we looking for? We're just looking for the coordinates of what? R prime. Those coordinates right there is what you're looking for. So from the origin, how far do we go over? 1, 2, 3. So we know we're at what? Positive 3. And from right here, how far do we go down? 1, 2, 3, 4, 5. So where would I be? And that's your answer. Right there. All right, here is the final problem. This is the kind of trickiest problem out of all of them. It says you need to reflect it across y equals negative x. Now, y equals negative x is a line where all of the y values are the negative x values. This is what that line looks like. I'll give you a chance to draw that line in. All right, I'm going to list P, Q, and R. I'm going to list their ordered pairs, just right here to the right. At P, we are at 1, 1. So our x value and our y value is at 1, 1. The Q, right here, 1, 2, 3, 4. Looks like we're at a 4 and a 4. And our R value is at a 3 and a 1. Over 3, up 1. Okay? So I'm going to show you guys, if we're reflecting it across y equals x, I'm going to show you how easy it is. You see, from here to right here, you're going basically across that square like that diagonal. All right? So I'm literally just going to go across that 1 unit, like one diagonal across. I'm going to put a point right here. I'm going to call that P prime. So I'm going to label the ordered pair, P prime. Now, where am I located? I'm located at a what? Negative 1 and a negative 1. Okay. Now, the next thing I'm going to do is I'm going to take R. Put Q prime, I'm going to do R prime. R prime is a little bit easier than Q prime, so I'm going to do R prime. So watch, I'm going to go over 1 diagonal, 2 diagonals, right? So I got to go over 2 diagonals. 1, 2. 1, 2, right here. This is going to be my R prime. So where am I located here? I'm located at a negative 1 and a negative 3. Interesting. Look what happened with this. If this was an X and a Y, what happened? It looked like this became the what? The negative Y and the what? Negative X. Let's see if that works without even doing anything. So this should be a what? It should be at a negative 4 and a negative 4. Let's see if it works. 1 diagonal, 2 diagonals, 3 diagonals, 4 diagonals. Yes, it works. 1, 2, 3, 4. Right here, this would be your Q prime. So what is the rule? What is the rule for y equals negative x? You could add this rule. What does x, y become? It becomes negative y and a negative x. That's the rule. Okay? And then I'm going to go ahead and just connect the dots. Kind of cool. Hopefully you guys can see how these are mirror images, how they reflect across. Now what does it ask us for? It says, what are the coordinates of what? R prime. So what are the coordinates of R prime? That part right there. That's the coordinates of R prime. All right? So make sure in your journal, what do you make sure you want to have in your journal? You want to make sure you have this chart in your journal so that you don't have to, that you can apply that chart whenever you're taking a test or a quiz. Have a good day.